Okay. Good afternoon, everyone. Good evening.
Good afternoon, sir. Good
So,
evening.
today we will talk about the cluster analysis. So, actually, we will see the examples. One of the example is we consider a clustering of consumer based on attitudes towards shopping. Based on the past research, six attitude variables were identified, and consumers were asked to express their degree of agreement with the following statement on a 1 to 7 scale. 1 means disagree, 7 means agree. So V1 is nothing but shopping is a fun. V2 is a shopping is bad for your budget. V3, I combine shopping with eating out. V4, I try to get the best buys when shopping. Next, I don't care about the shopping, and you can save lot of money by comparing price. So these are the six variables are there which are measured on a 1 to 7 point scale, and these are the corresponding observations given. So we have 20 respondents with us, and from 20 respondents we have collected this information. It is especially to identify the segmentation of a customer based on their shopping habits. So that means I wish to classify the customers by their shopping habits. Which kind of customers are there? So cluster analysis is nothing but it is a technique used to classify the object or cases into relatively homogeneous group called the clusters. So whenever you do the cluster analysis, clustering should be done in a such a way that within the group data are more or less homogeneous and between they are more or less heterogeneous. Object in each cluster tends to similar to each other and dissimilar object to the other cluster. So similar objects belong to the same clusters and dissimilar belong to the other. Cluster analysis is also called a classical analysis or numerical taxonomy. We'll be concerned with the clustering procedure that assign each object into one and only one clusters. So as I told you that cluster analysis is a classification technique, and we try to see that whenever we do the clustering, only one object belong to the one clusters. It is not like that the one object belong to the two different clusters. That is not possible. So that means whatever the clusters you are creating, they are mutually exclusive and exhaustive. Both cluster analysis and discriminant analysis are concerned with the classification. So in discriminant analysis, you can also do the classification, as well as in cluster analysis, you can also do the classification. However, in discriminant analysis required prior knowledge of the cluster or group membership for each object or case included to develop the classification rule. So in a discriminant analysis, we have some prior information about the group membership is with us, which can help you to classify the object. So that means some classification rule to classify the object into the one or other group. However, in a cluster analysis, there is no prior information about the group or cluster membership of any object. Groups are cluster Groups or clusters are suggested by the data, not defined a priori. So in a cluster analysis, we do not have any prior information available. So in the machine learning language, we call them as a unsupervised learning. Cluster analysis is a unsupervised learning technique, and discriminant analysis is said to be a supervising learning technique. That means when there is no prior information available, we call use the technique of classification is a cluster analysis, and when some prior information is available to you, then you can use the discriminant analysis for a classification technique. So it can be used for the segmenting the market. For example, consumer may be clustered on the basis of the benefits sought from the purchase of the product. Each clusters would consist of consumers who are relatively homogeneous in terms of the benefits they seek. This approach is called the benefit segmentation. So whenever the customers is classified as a group of the people who are benefiting or the who seek for the certain benefits, so that is nothing but a segmentation of a benefit clustering or the benefit segmentation, we can say that. So that means whenever they are more or less homogeneous informations are there, they club into the same group. It can be also useful to understanding buyer behaviors. Cluster analysis can be used to identify homogeneous group of buyers. Then the buying behavior of each group may be examined separately, as in the departmental stir project, where the respondents were clusters on the basis of the self-reported importance attached to each factors of the choice criteria utilized in the selection of a departmental store. So, if I am saying that why you have selected the specific departmental store, so you have collecting the several information on the same respondent, and by the that information we are classifying the respondents into the specific group. Okay, this kind of the people always select this kind of a stores. Cluster analysis has also been used to identify the kinds of strategies in automobile purchase are to obtain as a external information. For example, who is the economic minded customers, who is the luxury minded customers, or the group of the people who is looking for the some safety, group of the people is looking for the economy. So you have a group of the people who are looking for the economy. That means you have to come with the automobile which has the economic in price. So based on this segmentation, you can classify the group of the people, and then you try to study the each and every people who belong to that group. Identifying the new market opportunity by clustering brands and product competitive sets within the market can be determined. Brands in the same cluster compete more fiercely with each other than the brands in the other clusters. So whenever you have a several brands are there, the uses of the brand, what is the particular product, what is the objective of the brand, what are the contents, price and everything. So that means this similar kind of a brand belong to the same cluster. So you can identify who are the competitor in the market. So by doing that, you can identify the your nearer competitors using the cluster analysis. A firm can examine its current offering compared to those of its competitors to identify the potential new product opportunity. So by looking that, you can identify which kind of the product I should launch so that I can have a benefit. Selection of a test market by grouping cities into homogeneous cluster, it is possible to select comparable city to test various marketing strategy. So by looking at the homogeneous city, if you adopt the one marketing strategy in one city, which city has required the same marketing strategy. So by using the clustering analysis, you can identify these many cities require the common marketing strategy, and these many cities require the different kind of a marketing strategy. Then reducing data. So cluster analysis can be used as a general data reduction tools to develop clusters or subgroup of data that are more manageable than the individual observation. We cannot go to the every person and try to understand everyone. It is better that can we have a group of people who can have the common characteristics, so we can design a certain things for them. So suppose you have a thousand observations, thousand respondents are there. It is very difficult to study thousand respondents. So if that thousand respondent can be clubbed into the, or they can be divided into the four clusters, somewhere have the 500 respondents, somewhere have a 250, somewhere as the 115, somewhere as 100. So that means now you have to, instead of studying the thousand respondents, you have to study only four groups, and that is more easy to study these four groups rather than the studying the individuals. So subsequent multivariate analysis is conducted on the clustering rather than the one individual observation. So once the clustering is done, we can apply the different statistical analysis on the each cluster. For example, to describe differences in consumers' product usage behavior, the consumer may first cluster into the group, and the differences among the groups may then be examined using the multiple discriminant analysis. So first you try to convert into the group, and then once the groups are with you, that means all prior information of the grouping is with you. Now you can develop a discriminant analysis and perform the association rules to classify the object. There are various statistics are associated with the cluster analysis. So before discussing the statistics associated with cluster analysis, it should be mentioned that Most of the clustering methods are relatively simple procedures that are not supported by the extensive body of statistical reasoning. So we will not do the testing of hypothesis and other things over here. Most clustering methods are heuristics, which are based on the algorithm. So clustering are usually done based on the certain algorithm. Thus, cluster analysis contrasts sharply with analysis of variance, regression, discriminant analysis, and factor analysis, which are based upon an extensive body of statistical reasoning. So, in analysis of variance, regression, discriminant analysis, factor analysis, you have some statistical background and statistical theories associated with it. However, in cluster analysis, we are not using any statistical theory as such, or you can say that as compared to these many techniques. Although many clustering methods have the important statistical properties, and fundamental simplicity of this method needs to be recognized. So, following statistics we can use while performing the clustering analysis. One is a agglomeration schedule. Second one is a cluster centroid, cluster center, cluster membership, dendrigram. So, we will see the one by one. So, agglomeration schedule gives information on the objects or cases being combined at each stage of hierarchical clustering process. So we know that in a clustering procedure, there are two types of clustering techniques are there. One is a hierarchical clustering and second one is a non-hierarchical clustering. So hierarchical clustering has the two different form of clustering. One is a agglomerative method and second one is a divisive method. So in agglomerative methods, what we do in each step or in each process we will make a clusters. So initial in agglomeration what happen, each object become the clusters, and as soon as the fusion takes place it become they joined in the somewhere with the either object or fuse with the some clusters, and at the end of the day you have a everything is covered under the single clusters. So that is the concept of agglomeration schedule. But in divisive methods, we start with that. Let us say we have a one clusters and then we split up so that the splitting process is in such a way that each object become the clusters. We will use the cluster centroid. The cluster centroid is the mean value of the variables of all the cases or objects in a particular clusters. We will find out the mean of every variables in each cluster. So that is giving the cluster centroid. Cluster centers are the initial starting point in a non-hierarchical clustering. Clusters are built around the cluster seed. So as I said that another is approach is a non-hierarchical clustering. So the non-hierarchical clustering what happen? There is a we can use the partitioning methods or we call them as a k-mean clustering methods. The difference between the hierarchical and non-hierarchical, the non-hierarchical hierarchical has the demerit is that once the object is fused with the one cluster, there is no chance that that object can leave that cluster. However, in a non-hierarchical clustering, we can have that any time the object from one cluster to other clusters can be transferred in a such a way that the transferring expected value of p and k should be minimum or the distance should be minimum. So that is possible in a non-hierarchical clustering, but that is not possible in a clustering. Then you have a, of course, a object belong to the clusters. It is said to be a cluster member. Then we calculate the dendrigram. Dendrigram is nothing but it is a kind of a tree graph, which is a graphical device for displaying clustering results. Vertical line represent the clusters that are joined together, and the position of the line on the scale of indicate the distance of each clusters were joined. So we will see the dendrigram. I will show you that what is the vertical line, why it is said to be, these are said to be distance. So dendrigram is mainly useful to identify the number of clusters. As we know that the number of clusters are always less than or equal to n upon p plus 1, where p is the number of variables and n is the number of observations. Now, distance between the cluster centers. So this distance indicate how separated the individual pair of clusters are. Clusters that are widely separated are distinct and therefore desirable. So you always try to find out the difference of a clusters. If the one cluster has difference here, another cluster has difference here, and if the distance is far away, then we say that the the clustering is appropriate, because our objective is that within the data must be homogeneous and between the data must be heterogeneous. You can find out the similarity or distance coefficient matrix. So similarity or distance coefficient matrix is a lower triangular matrix containing the pair, that is the distances between the object. So when you do the cluster analysis, we always try to either, if it is a quantitative, we calculate the distance, and distance is mainly we are calculating is a Euclidean distance. Okay, there are several other distances are there, but most of the times we will use the Euclidean distance. Then there is a Chebyshev distance is there. Euclidean distance has the demerit that it is affected by the scale of measurement, but Chebyshev distance is a kind of a distance which is not affected by the scale of measurement. When people can also use the city block distance matrix, people can also use the Minkowski distance, people can use the square of Euclidean distance. Sometimes if your data is a qualitative, you can use the similarity measures, and then by using the similarity measures, you can calculate the coefficient matrix. Ultimately, based on the distance matrix or similarity coefficient matrix, you have to go further. Okay, which object is going to fuse which each other. The forming of the clusters required, there are various linkage methods are there. One is a single linkage method. There is a complete linkage method. There is a average linkage method. There is a word error methods. There is a, which one more? Anyone?
Median.
Median linkage method, centroid methods. So there are several methods are there for a forming of a cluster. But anyhow, if we when we perform the step-by-step cluster analysis, what are the things we have to remember? So first, you have to formulate the problem. Second, that which distance are you going to select? So that means select the distance measure. After selecting the distance, select a clustering procedure, whether you are using the single linkage, whether you are using complete linkage, whether you are using centroid method, whether you are using the word uh, errors method, whether you are using the average linkage. So likewise, so you have to select the clustering procedure. First, you have to select the distance. Of course, when you have the data is of a qualitative, then you have to use the, instead of the distance matrix, you have to find out similarity coefficient matrix. If it is a quantitative, you have to calculate the distance matrix. And as I said that there are various distances are that we will see also. Once the clustering procedure is over, clustering procedure, once the forming of the clustering methods we have selected, and then we will go for the hierarchical clustering approach, either agglomerative or divisive method, but most of the time in practical agglomerative methods are more useful. So we will use the agglomerative methods, we will make the dendrogram, and based on the dendrogram we will decide the number of clusters. And then we will assess the validity of the clustering, that means whether the clustering is appropriate or not. So what is the formulate of the problem? Perhaps the most important part of formulation uh, the clustering problem is selection the variables on which the clustering is based. The important thing is that which variables are really necessary for clustering. Inclusion of even one or two irrelevant variables may distort an otherwise useful for clustering solution. So if you have taken the variables which are of irrelevant, so then it may disturb your clustering, and if you have taken the appropriate variable, it is giving the important clustering solution. Basically, the set of variables selected should describe the similarity between the objects in terms that are relevant in the marketing research problem. The variables should be selected based on the past research. Either if you are doing the first time, look at the literature review and identify that the people who have done the clustering, which kind of the variables they have taken, or which kind of the theory or of consideration theory you are using, or consideration of hypothesis being tested. So in exploratory research, the researchers should exercise the judgment and institution. By uh, if you are talking about the uh, price of any commodity, so you have to also study the test of the individual. According to the test, if the individual is believes in the good test, or for example, when you say the test, it is not only food item, But if you are talking about the car, then you say that what is the taste of the people. That means whether the individual is a economic minded or it is a luxury minded. So price is the one of the variable which is associated with the test. So that means price and test both should be together while forming the clustering. Then select a distance or similarity measures. Because the objective of clustering is to group similar objects together, some measure is needed to assess how similar or different the objects are. The most common approach is measure of similarity in terms of distance between the pair of objects. Objects with the smaller distance between them are more similar to each other than are those at the larger distance. So as I said that if the distance between the two objects is small, then we say that they belong to the same group. If distance between two objects is large, they belong to the different group. The most commonly used measure of similarity is the Euclidean distance or its square. The Euclidean distance is the square root of the sum of square difference in value of each variable. As I told you in the theory classes, if the two objects are given, object 1 and 2, it has the variable x1, x2, x3, then you have to see the difference of x1 in the object 1 and 2, and then you have to take square difference of object 2 into the object 1 and 2 of a variable 2, then their square difference of object 1 and 2 for a variable 3 and their square, and then make the sum and then square root of all. It is giving the Euclidean distance between the two objects. Other distance measure are also available, like the city block or the Manhattan distance between the two objects is the sum of the absolute difference in the value of each variable. Instead of taking the square, you just take the sum of absolute difference of two cases. That will give you the city block Manhattan distance, and the Chebyshev distance between the two objects is the maximum absolute difference in the values of the variable. So this is another Chebyshev that you take the absolute difference of two objects, and that out of which has the maximum value, that value will be selected as a in a distance matrix. Now select a clustering procedure. Clustering procedure can be hierarchical or non-hierarchical or other procedure. Hierarchical clustering is characterized by the development of a hierarchy of a tree-like structure. Tree में कैसे होता है, root को थोड़ा जोड़ेंगे तो और ऊपर होएगा, then it becomes the entire tree. Hierarchical methods can be of a two types, that is of agglomerative or divisor. Agglomerative clustering starts with each object in a separate cluster. So in agglomerative, what we start, that each object, what is object? Object in our case is that rows. We have a data matrix with us. So rows are said to be a cases and columns are said to be a variable. So the whatever the rows are there, we call them as a object. So we start that each object. Suppose we have 100 observation, then we say that initially we have 100 clusters. Clusters are formed by grouping object into the bigger and bigger clusters. This process is continued that all objects are the members of a single cluster. So you have to start with that all clusters are individuals, and slowly and gradually they are fusing each other, and the clustering is done in such a way that all belong to the single clusters. In divisive methods, what that? It starts with all the objects belong into the same clusters, and clusters are split until each object becomes the separate clusters. So agglomerative it is a forward, so then divisive is a backward method. But as I told you that agglomerative methods are more commonly used in the marketing research, and they consist of a linkage method, like it is a together linkage method. It is a error sum of square or variance methods and centroid method. So linkage method includes the single linkage. So as I complete linkage and everything. If you look at this graph, clustering procedure is of either hierarchical or it is of a non-hierarchical, or other means where you can use the hierarchical as well as the non-hierarchical. Hierarchical clustering is further classified in two parts, that agglomerative or divisive methods. Non-hierarchical is a sequential threshold method, parallel threshold method, and optimization partitioning method. So optimization of partitioning method is nothing but k-mean procedure. And other is a two, where you can use the hierarchical as well as the non-hierarchical. So in agglomerative, we are using the three different linkage methods. One is a linkage methods, variance methods, and centroid methods. So linkage method is of a single linkage. Single means you are trying to identify the smallest distance between two objects. Complete linkage, that means you are trying to identify the maximum distance between the two objects. And average linkage is that, okay, suppose the some cluster is made and one of the object is fused, then you try to identify each object distance from the each member of clusters and then find out that average distance, and whichever is the smallest value of average distance, that will be considered to be a next object to the fuse with the clusters. So that is called the average linkage. In a variance Schwarz methods, we calculate the mean of each object. Then we will try to find out the distance from the each variable value in an object from its mean. Then take the square and their sum, and then find out whichever is the smaller value. So that is the nothing but the Schwarz methods. And in centroid method, you can use the either average centroid method or the median as a centroid method. So this is what the single linkage. It is also known as a nearest neighboring clustering. This is one of the oldest and the most famous hierarchical technique. The distance between two groups is defined as the distance between their two closest members. So when two members are closest, whatever the methods you are trying to identify, that is called the single linkage. It is often yield clustering in which individuals are added sequentially to single group. So every time you are adding the object into the other clusters, and finally you are forming a single group. Complete linkage is nothing but it is a furthest neighbor. That means maximum distance between two objects. So that is a complete linkage methods. These method yield clusters that are well separated and compact. But when we do the hierarchical clustering, we always first cluster is formed based on the single linkage methods. Then second and third, it depends on the methods you have adopted. So average linkage is nothing but it is a called the weighted pair group method. This algorithm defines the distance between the group as the average distance between the each of member, weighted so that the two groups have the equal influence on the final result. And that is what the Watt's minimum variance. As I said that with this method, groups are formed so that the pooled within the group's sum of square is minimized. That is, each step the two clusters are fused, which result in the least increase in the pooled within group of sum of variance. So you find out the within group sum of variance, and whichever has the minimum, that is the fused with the in the next round of the clustering procedure. So similarly, this is you have a non-hierarchical clustering in which containing the sequential threshold method, parallel and optimization partition methods. Two major disadvantages of a non-hierarchical procedure are that number of clusters may be specified. So when you do the uh, clustering in a non-hierarchical clustering, there is a disadvantage. What is that? You should know the number of clusters first. And second is that you have to identify the select the arbitrary, you have to select the clusters. Further, the clustering results may depend on the how centers are selected. So first is the that what is the value of k, that means number of clusters, and what should be the value of the center as an initial clustering solution. So these are the always a problem. Thus the clustering may result depends on the order of observation data. Yet non-hierarchical clustering is faster than the hierarchical method and has merit when the number of objects belong is a large. So when the number of groups, number of the cases or objects are more, it is always advisable that you should go for the non-hierarchical clustering rather than the hierarchical clustering. Sometimes it is saying that you use the both. First you perform the initial clustering solution based on the hierarchical procedures such as the average linkage or Dward method of clustering or cluster centroid, and that give you the some idea about the number of clusters, and then use the optimized partitioning method or the k-mean clustering procedures. So that is what it is saying. The other clustering procedure is one particular interest is two-step clustering analysis. This procedure can automatically determine the optimal number of clusters by comparing the value of model choice criteria across the different clustering solution. So you have some different criteria. As I told you that you have to calculate the within variance and between variance. So if you find out the ratio of the between to within, and if it is the larger, then what we say that the clustering solution is a good. So why the within variance is low? It means that the object belong to the same group are more or less similar. So that means the variability is low. And between they are more, it means between they are more, it means between they are more, it means that there is a more difference among the clusters, and that is what we are actually looking for. Acha. You can also identify the clustering, whether the clustering good or not. It is based on the either you can use the BIC or AIC. Lower the BIC and lower the AIC, you can say that the clustering is a good method. Choice of clustering method and choice of distance measure are interrelated. For example, squared Euclidean distance should be used with the Watt and centroid method. And several non-hierarchical procedures also use as a squared Euclidean distance in the two-step procedure. So choice of clustering and the distance, it's are related. So it is up to you. It is advisable that square Euclidean distance use as a technique of forming the clusters when you can use the wide or centroid methods. Now you have to decide the number of clusters. So that is the always problem, how to find out the number of clusters. So some guidelines are there. You can have either theoretical or conceptual or practical consideration suggest the number of clusters. For example, if the purpose of clustering is to identify the market segment, management want to particular number of clusters. If I wish to study 4 segments, so they will say that I wish to study only 4 clusters. In hierarchical clustering, the distance at which clusters are combined can be used as a criteria. This information can be used from the agglomeration schedule or from the dendrigram. So by looking at the dendrigram, you can identify the clusters. So dendrigram is nothing but, as I say, that it is a program module build a cluster hierarchy that is commonly displayed as a tree diagram. So whenever you have the clustering solution is with you, you just make a plot of that. It is giving the dendrigram. They begin with each object is a separate clusters, and each step the two clusters that are similar are joined into a single new cluster, and once fused, objects are never separated. So in hierarchical clustering, once the object is fused, they are not going to separate it. However, in non-hierarchical clustering, that is the advantage. Once the object is fused with one cluster, they can have a chance to relocate to the other clusters. You always find out the ratio of total within group variance to between group variance can be plotted against the number of clusters. The point at which the elbow or sharp bend occurs indicate an appropriate number of clusters. So you can make a find out the Wilks lambda. It is saying that the within variance to the total variance W by T. And if you plot this W by T, we call them as a lambda. If the lambda against the number of clusters, wherever the you observe the elbow and wherever the value of the smaller value of the within variance to the total variance, that means that many number of clusters are worthwhile or you can proceed. Once the clustering is done, you have to interpret and you have to profile the clusters. So interpreting and profiling clusters involves examining the cluster centroid. The centroids represent the mean value of objects contained in the clusters on each variable. So what you have to do, you have to, once the clustering is done, but where the objects are clustered, so you have to find out the cluster centroid of each cluster. Okay, you have to find out because there are p variables. So there are p variables are in each cluster. You have to find out the mean of that p variables. So you can have a p means because there are n1 observation, n2 observation, and there are nk because there are k clusters, and n1 plus n2 plus nk is a total number of observation. The centroid enable us to describe the each cluster by assigning its name or label. If the clustering program does not print this information, it may be obtained through the discriminant analysis. So by looking at the name of the variables, you can also give the name of the clusterings. It can also helpful to profile the clusters in terms of variables that were not used for the clustering. They may include in demographic, psychographic, product usage, media usage, and other variables. Further profiling may done in terms of demographic and psychographic variable to target marketing offers for each other. Okay. And once it is with you, you can perform the discriminant analysis, one-way analysis of variance and other things. Now, to identify whether the clustering is done or appropriate or not. So, of course, you have to perform the cluster analysis by using the different distance measure. Once you perform the cluster analysis using the, let us say, Euclidean distance, then second time you perform with the city block distance, Chebyshev distance, and then find out the solution of a clusters, whether the solutions are nearer or different. Use difference method of comparing. You can take the single linkage, you can take the complete linkage. So don't just stick with the one method and give the solution. Try to use the various method and see that if I am using the different method, is there any change in the clustering solution? If it is change, how much amount of the clusters are changed? So that you can also perform. Sometimes you can also that you split the data randomly into the two part and perform clustering on a separate half and compare cluster centroid across the two subsamples. So suppose you have 1,000 observation, randomly you make a group of 500, randomly you make another 500, and now in a 500 perform the clustering, in a this 500 perform the clustering, find out their centroid of a first group, then find out the centroid of this group, and if this group are nearer or they are very far away from each other. So in that way you can also identify whether the clustering is appropriate or not. Sometimes what happen, if you feel that the sum of the variables is not suitable, so delete that variable, or you can say that the let us if you have a 10 variables are there, delete randomly one variable and then perform the clustering based on the 9 variables. कंपेयर द रिजल्ट विद दोज ऑब्टेन क्लस्टरिंग बेस्ड ऑन द एंटायर सेट ऑफ वेरिएबल. तो आपने एक वेरिएबल को रिमूव किया, 9 वेरिएबल के बेस पे आपने क्लस्टरिंग सॉल्यूशन निकाला और एक बार सारे के सारे वेरिएबल लेके आपने निकाला, दोनों में कोई चेंज आ रहा है, ठीक है? तो दैट यू हैव टू सी. In non-hierarchical clustering, the solution depends on the order of cases of the data. Make multiple runs using the order of cases until the solution stabilize. So there are various methods to verify whether the clustering is appropriate or not. So first is that you take the different measure and then try to compare the various clustering solution. Second is that you use the different forming methods like the linkage methods, word methods or centroid methods and then try to compare the solution. Third is that okay, you divide your data into the two halves and then for each half perform the clustering solution and then try to compare is there any significant difference among the solutions or not. Another is that okay, you delete one variables and perform the clustering solution on the rest variables, and one is that you perform the based on all variables and then compare. Or you can also compare based on the, as I told you that within variance and between variance also. So that we will see. So this is what the basic purpose of a cluster analysis. Why the cluster analysis? Cluster analysis is a data reduction technique and the reduction is based on the row. Sometimes it is also said to be a classification technique. Okay, classification is done based on the object. Cluster analysis is also said to be unsupervised learning because we do not require any prior information for the clustering. Based on the variables, we try to identify which objects belong to which group. So of course, it is of the we will try to find out the similarity and dissimilarity. Similar object belong to the same group, dissimilar object belong to the different group. We try to find the cluster in a such a way that within the data homogeneous, between data are heterogeneous. Of course, there are various methods for a clustering. So when you talk about the quantitative data, okay, then we use the distance matrix, and when you talk about the qualitative data, we uh, find out the similarity coefficient matrix. Two types of the clustering procedure are there, hierarchical as well as the non-hierarchical, and other is a two-step procedure. So hierarchical clustering also divide into two part, agglomerative and divisive method. Non-hierarchical is divided into the three part and other is a two-step, hierarchical as well as the non-hierarchical. So once the hierarchical method is identified. You have gone for the agglomerative methods. You calculate the distance methods. Distance method. So distance methods, you can have the various distance method: Euclidean distance, city block distance, Minkowski distance, Chebyshev distance, Euclidean square Euclidean distance. Likewise. So based on that distance matrix, you will try to go for the linkage methods. So linkage may be single linkage, complete linkage, or average linkage. Single means the smallest distance, linkage between the farthest distance between the two objects, and average means it is a weighted average distance you are calculating, and the smaller the value of weighted average is considered to be a fusion of a this. The hierarchical method is a kind of that, or in agglomerative, that we start that each object is a clusters, and then every time you are calculating the distance and the smaller distance, or based on the linkage methods, we are fusing the clusters, and finally the process is continued that all belong to the single clusters. In divisive method, that we start with the single clusters and we split the cluster in a such a way that each object become the clusters. But the disadvantage of a hierarchical clustering method is that once the object is fused with the some cluster, fuse means किसी के साथ जुड़ गया, you cannot remove from that. Okay, but that's why we will go for the non-hierarchical cluster, where we can allow the object from move from one cluster to other clusters in each steps. Based on that, the distance should be minimum among the object. So non-hierarchical clustering is mainly used when the data size is very large. Other thing is that non-hierarchical clustering requires the number of clusters and initial centroid solutions. So that you have to take the arbitrary. So that is always the problem with the non-hierarchical clusters, how to identify the number of clusters. Either you can say that number of clusters is less than or equal to n upon p plus 1. P is a number of variable, n is a number of observation. Or you can perform the hierarchical clustering, find out the dendrigram. So dendrigram is nothing but it is a graph of the distance versus the object. Okay, so it is a kind of a tree structure, and which can help you to decide the number of clusters. So once the clusters are with you, you can go for the non-hierarchical clusters, and once the non-hierarchical clustering and the reliability of the cluster is identified, you have to perform the profiling of the clusters. So we will see the one example. Suppose we have a data, as I was talking about the data of the buying behavior. So first I will import the data. So of course the command is a read.table. Why? Because I have a data file in the text format. Then I will browse the file by using the file.choose. And because the first row is a variable, so I have given the header equal to true. In my data, the first column is a serial number, so I have to remove that serial number because serial number does not help me. If data are measured on a different scale, as I say that the Euclidean distance is affected by the measurement of scale, and if I wish to use the Euclidean distance, so first I have to standardize it if the data are measured on a different scale. If it is on a same scale, there is no need. So to standardize, the command name is you can use the scale. Then you can calculate the distance matrix. Euclidean distance is a by default command of a dist. This is calculating the distance, and I will store into this. Then I will perform the hierarchical clustering. Command name is a heclust. So you just supply this distance matrix, it will give you the hierarchical clustering. And then I will perform the dendrigram. Plot. So HC is my clustering, hierarchical clustering solution is in HC. So I have to find out the plot of this. Label equal to false, it means that it does not give the numbers. Otherwise, if there are large data, if you print the numbers in the bottom, it is very difficult to read. And then I will find out the, to make dendrigram, I can directly also write the plot of HC. Then identify the number of clusters. So you can identify the number of clusters based on the dendrigram. Sometimes dendrigram is also difficult to interpret. So in R, there is a facility of a command that nbclust, which is the part of nbclust library, which can select the clusters based on the certain criteria. So it is saying that if number of clusters satisfy the maximum criteria, that means that many clusters can be plausible. So that you can also make a bar plot, and the command for the bar plot is you have to find out nc dot best. It has contained several criteria, and table is finding their frequency, and then you can make the bar plot. So it will help you to identify the number of clusters. Once the number of clusters are identified, you have to perform the non-hierarchical clustering, which is known as a k-mean procedure. So command name is a k-mean. You have to supply your original data, and then you have to give the number of clusters obtained from this. By default, the method is a centroid method. Then once this, you can make the plot of this. So you have a data, and you have the clusters. In CL, I have stored the entire solution. So it has the one of the cluster, either one or two, and then you can load the data. Then you can have idea that how the data are shown in the diagram. Then you can plot the center value. So you can also find out the centers, and then you can view the file. You can split the data by the clusters, and by looking at the profiling of the variables, characteristics of variables, you can give the name of a clusters. So we will use the file. This is another file of a alcohol. I told you the wine example, which is available in the RETL library. So I have taken also that data and I have shown you. But we will start with the first this. Any question up to this?
No, sir.
I think I am so fast, but I have already discussed the theory with you, but it is a just quick revision of that. So first I will show you that how the dendrogram is helpful to you. So what happened? I have just drawn 100 random numbers whose mean is 0 and standard deviation is 0.3. Here I have drawn the 100 random numbers with mean 1 and standard deviation 0.3. It means that I have generated a data of a normal population with mean 0 and standard deviation is 0.3. Another population is between 1 and standard deviation 0.3. So of course, when you divide this 100 into the 50-50, okay, I have written column 2 equal to, that means 50 observation in each column. There are two columns. So this is, and here 50, because I am R binding, that means I am merging. And if I am making this graph just for understanding, so this is my X. Okay. Then I will find out the distance matrix of this X and find out their cluster solution. So it is giving the distance, and then I will find out the plot. So this is the dendrogram. Okay. Here each object is the clusters. This is the one object. This is another third, fourth, likewise. So each object initially is a clusters. This object is fused with this and form a clone clusters, and this object is fused with this and form another clusters. This object has fused this with and making the another clusters likewise. And it is hierarchical procedure so that all clusters belong to the single clusters. So here you can see that this is forming one clusters and this is forming the another clusters. Why? Because it has the mean 0 and it has the mean 1. Okay, just show you okay, how to recognize the number of clusters. Now if I am making the, because I know that there are two clusters are there. Similarly, if I am making the three clusters, one has the mean 0, another has the mean 1, another has the mean 2. Okay, same. So you can see that this is the one cluster, this is the another cluster, and this is the another cluster. Somebody said, sir, I may say this is a one cluster, this is a 2, 3, 4. So more clusters are also not important, because then what is the fun of making the clusters? So we try to see that we should have a minimum clusters and which can explain the maximum variation. Okay. So let us go with the, if I wish to make the plot of this, I will show you about this same data. I will take this again to find out the clustering solution. How many clusters are there? Two clusters. I am giving the columns names because x has the my data. Okay, this is the data. So you can see that there is no name of the column is given. It is only written like that 1 and 2. So I wish to give that here it is x and this is the y. So command name I can use as column names. किसका column name? x का क्या देना है? X and y. If you have now you can see that now it has the name x and y. So you can give the name accordingly as per your requirement. You have to write in double thing. Then here if I wish to perform the clustering solution because I have initially two clusters, so I can find out the k-mean command. I have to supply the data and how many clusters? So there are two clusters. And when I am giving in the bracket entire things, that means what happen? It is directly printing the value. So you can see that. What is the mean of the first variable in the cluster 1? It is a 0.0. What is the mean of the second variable in the cluster 1? It is a 1 point. So as you know that I have taken the data 50 observation from mean 0 in the column 1 and in the column 2 50 observation which has the mean 0. Rest I have r bind the observation 50 उसका mean क्या था 1 था और यहाँ पे क्या था mean is near to 1. So that is you can see that. And these are the saying that this many observation पहले 50 से कहाँ जाएंगे क्लस्टर 1 में क्यों क्योंकि देयर मीन इज नियर टू 0 एंड इसका क्या है लास्ट 50 कहाँ जाएंगे तो आप देखो 51 से ऑब्जेक्ट कौन से थे 51 से देखो ये सारी वैल्यू जिसकी वैल्यू मोर और लेस 1 के आसपास है ठीक है तो जिसका मीन क्या है 1 के आसपास तो वो सारे उसने कहाँ दिए इट हैज गिवन इन द क्लस्टर 2 देन as I told you that you have to find out the within sum of variance तो within sum of variance पहले क्लस्टर का कितना है 9.6 दूसरे का कितना है ये है एंड बिटवीन बाय टोटल कितना है दिस तो 74.8% ऑफ क्लासिफिकेशन इज डन बाय क्लस्टर तो दिस इज क्लस्टरिंग सॉल्यूशन एक्यूरेसी कितनी है 74.8% and these are their arguments if I wish to find out the clusters so I can just give the CL dollar the cluster it is giving this value. I wish to find out the centers, then it is giving the above value. If I wish to find out the total SS, within SS, total dot within SS, between SS, size, iteration, so it is giving the different value. For example, I will show you. We will find out CL dollar. Dollar करेंगे तो क्या चाहिए within चाहिए आ गया 9.6 and 8.2 आप बोले कि नहीं हमें between चाहिए CL डॉलर क्या चाहिए आपको betweenness so this has given the betweenness is a 53.0997 so likewise okay so now we will just why I have shown you this because मैंने पहले से ही जानता हूँ I know that I have only taken the two clusters so I have already taken the data from a two population मैंने क्या किया पहले 50 ऑब्जर्वेशन जिसका मीन 0 है और बाकी के 50 ऑब्जर्वेशन जिसका मीन 1 है दोनों को मिला के एक वेरिएबल बनाया दूसरा वेरिएबल किसको बनाया जिसके 50 ऑब्जर्वेशन मीन 0 है और दूसरे लास्ट 50 में क्या है मीन 1 है तो मैंने क्या किया मुझे पता है कि पहले 50 ऑब्जर्वेशन है ग्रुप वेरिएबल 1 और 2 में दोनों में क्या है दे आर फ्रॉम मीन 0 और दूसरे 50 में 1 में तो जब भी मैं क्लस्टरिंग करूंगा तो मुझे रिजल्ट क्या मिलेगा result I will get separate and that is what I have performed from the clustering analysis using the hierarchical clustering. I observed the two clusters and then I have performed the k-mean clustering and then I have find out their clusters and then this okay suppose कोई कहे कि नहीं मुझे अभी क्लस्टरिंग का सॉल्यूशन ये यहाँ निकाला आपने तो ये आ गए क्लस्टर्स कौन से क्लस्टर्स है ओके उसके बाद आपने क्या कहा मुझे प्लॉट निकालना है तो एक्स में ओरिजिनल डेटा है एंड सीएल में क्या है क्लस्टर्स है कॉलम में। तो इफ यू लुक एट द प्लॉट, ये पहले जो है जिसका मीन का है 0 के आसपास है, और अब देखो ये दूसरा है उसका मीन कहाँ पे 1 के आसपास है। तो इट इज शोइंग देयर डेटा। नाउ आई विश टू put the center over here, centroid value which I have obtained. So you can use this command and this is the size, and आपको किस हिसाब से चाहिए उस हिसाब से आप दे सकते हैं। तो you can see that this is the mean, तो आ गया 0 के आसपास, इसका मीन क्या है 1 के आसपास। तो दिस इज नथिंग बट दी योर क्लस्टरिंग। ये तो हमने पहले किया था इसलिए हमें पता है कि ऐसा आएगा। नहीं पता होता तो आप डेटा एनालिसिस करके वट एवर यू ऑब्टेन एंड इट व्हेन यू मेक द प्लॉट इट विल गिव यू द आइडिया। और सपोज कोई बोले कि नहीं मुझे अभी क्लस्टर्स के अंदर डेटा क्या है तो स्प्लिट करना है, स्प्लिट डेटा बाय द क्लस्टर्स। तो अब देखो पहले 50 ऑब्जर्वेशन जो अपने थे, मैंने 100 डेटा कलेक्ट किया था जिसका मीन 0 है, तो ऑल बिलोंग टू दी क्लस्टर 1 जिसका मीन 0 है, और इसका मीन क्या है 1 के आसपास है। यू कैन फाइंड आउट द मीन ऑफ ए, क्या आता है देखते हैं। ओके इसमें काम नहीं करेगा, $1 करना पड़ेगा और फिर उसका आप क्या करो मीन फाइंड करो। तो अब देखो मीन कितना 0 है, सेकेंड का करेंगे तो मीन इज नियर टू 1, so that means the clustering is appropriate. Now we will go with the our attitude data, बाइंग बिहेवियर का जो आपके पास है उसके ऊपर बात करते हैं क्या हो रहा है। So as I told that read dot data, read dot table, I have a this is the attitude data, मैंने attitude का लिया है कि बाइंग बिहेवियर, देख लेते हैं इसमें 6 वेरिएबल एंड 20, ओके। So these are the data, okay. So as I said that the first variable is not important, it is guess number. I am interested only this 6, so I will just remove the first variable by using the this command data equal to data. डेटा में मेरे पास 7 वेरिएबल है, उसमें से मैंने पहला कॉलम क्या किया रिमूव किया एंड देन अगेन स्टोर इनटू द वेरिएबल डेटा, ओके। एंड आई विल शो यू द हेड। So you can see that the first variables now it is removed, and again that whatever the changes of the data file I have stored into the again same variable, and then I will calculate the distance matrix. So what is the order of this? If there are 3 cases, what is the order of distance matrix? आप ढूंढेंगे ना पहले का दूसरे के साथ, पहले का तीसरे के साथ, दूसरे का पहले के साथ, लाइकवाइज। तो इट इज अ 3x3, तो यहाँ 20 है तो कितना आएगा उसका ऑर्डर 20x20। तो दिस इज द डिस्टेंस मैट्रिक्स, ओके। इट इज अ सिमेट्रिक, व्हाई? बिकॉज पहले और दूसरे का जो डिस्टेंस है वही का वही क्या होगा दूसरे और पहले का होगा, ओके। तो दैट इज हाउ इट इज ए सिमेट्रिक मैट्रिक्स। और खुद का डिस्टेंस क्या होगा खुद के साथ 0। एनी हाउ हमें डिस्टेंस मैट्रिक्स, आपके पास छोटा एग्जाम्पल है तो देखना आसान है। देन as I told you that perform the hierarchical clustering, आपको HC प्रिंट करेंगे तो यू कैन गेट द सॉल्यूशन आल्सो कि हाउ मेनी क्लस्टर्स आर देयर। तो यहाँ से नहीं, तो आपने क्या किया, यू हैव अप्लाइड द हायरार्किकल क्लस्टरिंग। बाय डिफॉल्ट मेथड कौन सा लिया है, कंप्लीट लिंकेज मेथड यूज किया है। डिस्टेंस कौन सा यूज किया है, यूक्लिडियन। एंड कितने ऑब्जेक्ट्स है, तो 20 ऑब्जर्वेशंस आर देयर, तो 20 ऑब्जेक्ट्स आर देयर। देन यू हैव परफॉर्म दी, यहाँ पे फॉल्स देने का पर्पस क्या है, नीचे 1 2 3 लिख के नहीं आएगा। आई विल शो यू, सिंपली ऐसा लिखता हो तो क्या आएगा, देखो ये सारे आ गए। कि फर्स्ट 2 and 13 आर मर्ज, यहाँ पे क्या हुआ 5 and 11 इज मर्ज, उसके बाद दिस मर्ज विथ 9 एंड दिस ऑल मर्ज विथ द 20 एंड ये सारा मर्ज किसके साथ हुआ, इनके साथ। तो हाउ मेनी क्लस्टर्स आर देयर, 1 2 and 3। यहां से हमें पता चल रहा है कि देयर आर 3 क्लस्टर्स आर पॉसिबल। गेटिंग माय पॉइंट? दिस इज द वन क्लस्टर, this is the another clusters and this is the another, so you can see that there are 3 clusters can be possible। लेकिन फिर भी, और यहाँ पे फॉल्स देंगे तो क्या आएगा, नंबर्स नहीं आएगा प्लॉट में, तो नंबर चला गया। आपको नंबर्स रखना है तो यू कैन डायरेक्टली गिव बाय डिफॉल्ट यह ट्रू होता है नंबर्स, ऑब्जेक्ट के नंबर। और दिस इज द हाइट, तो हाइट इज नथिंग बट द डिस्टेंस बिटवीन दिस टू। ये हाइट किसकी है, तो डिस्टेंस यहां से यहां जा रहा है, तो डिस्टेंस बिटवीन दिस टू ऑब्जेक्ट। ओके, तो हाइट इज नथिंग बट इट इज शोइंग द डिस्टेंस। एट लास्ट ये सब क्लस्टरिंग होगा, उसका मिनिमम डिस्टेंस कौन सा है, तो जो डिस्टेंस होगा दैट विल बी द हाइट। इट इज कॉल्ड द डेंडोग्राम। तो अगर फॉल्स दिया है तो आपको नंबर्स नहीं मिलेंगे, ठीक है। और आपने ट्रू दिया, मतलब कुछ नहीं दिया, तो आपको नंबर्स मिलेंगे। तो अभी फिलहाल डेटा कम है तो हम ये नंबर्स वाला प्लॉट लेते हैं। इफ 1000 नंबर आर देयर देन ये इतना खराब दिखेगा कि आपको मजा नहीं आएगा, इसलिए उस टाइम पे आपको फॉल्स रखना है। नाउ एज आई टोल्ड यू दैट देयर इज अ नीड ऑफ अ लाइब्रेरी, so I have to install the package। कौन सा पैकेज है, nb cluster। So I will install the package, it will take the corresponding all dependency। Okay, the package is successfully installed and I will perform the same command name is also same, nb cluster। You have to supply the data। मिनिमम नंबर ऑफ क्लस्टर कहां से शुरू करेंगे, 2। मैक्सिमम कितने हो गए, यहां आप दे सकते हैं आपको ज्यादा देना है तो, लेकिन आप कैलकुलेट करो। डेंडोग्राम कितना दिखा रहा है, 3 दिखा रहा है, फिर भी हम इसको 6 तक ले जा रहे हैं। दूसरा दूसरा क्या किया हमने, हमारे पास एक है n इज इक्वल टू 20 है, p कितना है 6 वेरिएबल, 6 प्लस 1 तो कितना हो 7, तो 20/7 कितना हुआ, ऑलमोस्ट 7 3 जा 21, तो ऑलमोस्ट 3 के आसपास। तो वो भी क्राइटेरिया जो अपना है k इज लेस देन इक्वल टू n अपॉन p प्लस 1, इट इज ऑल्सो सेइंग दैट इट इज नियर टू 3। डेंडोग्राम इज ऑल्सो सेइंग नियर टू 3। मेथड्स यहाँ पे कौन सी यूज करेंगे, k मीन क्लस्टरिंग। तो आप देखो जैसे आपने रन किया, इट इज गिविंग दिस प्लॉट, नंबर ऑफ क्लस्टर से डी इंडेक्स। तो यहाँ पे एल्बो कहाँ आ रहा है, यहाँ पे, तो ये क्या दिखा रहा है, नंबर ऑफ क्लस्टर्स आर 3। यहाँ पे सेकेंड डेरिवेटिव में क्या देखना है, सबसे टॉप वाला देखने का, इट इज शोइंग दैट नंबर ऑफ क्लस्टर्स आर ऑल्सो 3। डेरिवेटिव इंडेक्स वैल्यू एंड सेकेंड डिफरेंस डी इंडेक्स वैल्यू। वेल उससे आपको समझ में नहीं आया तो चिंता नहीं करने का, मेक द बार प्लॉट एज आई टोल्ड यू। So it is saying that 3 clusters satisfied by the maximum criteria। कितने, तो 18 जितने क्राइटेरिया है, which is saying that number of clusters are 3। What are these criteria? तो यहाँ पे आपने जैसे n से लिखा तो these many criteria are there। ये सारे क्राइटेरिया है, CH, हैरिंगटन, CCC, स्कोर, मेट्रियोट। तो लाइकवाइज कितने क्राइटेरिया है, ऑलमोस्ट 33 जितने क्राइटेरिया है, एंड आउट ऑफ दिस दे आर सेइंग दैट 3 क्लस्टर्स आर पॉसिबल। तो यहाँ पे जो आपका पार्टीशन है उसके, तो वी हैव टू टेक द डिसीजन बेस्ड ऑन दिस। व्हेन यू आर यूजिंग द आर, वी हैव दिस लाइब्रेरी, इट कैन हेल्प यू टू आइडेंटिफाई। तो बेस्ड ऑन डेंडोग्राम इट इज सेइंग दैट 3 क्लस्टर्स आर पॉसिबल। बाद में हमारा जो k इज लेस देन इक्वल टू n अपॉन p प्लस 1, इट इज ऑल्सो सजेस्टिंग, एंड द नंबर ऑफ क्राइटेरिया, maximum number of criteria satisfying that the 3 clusters are possible। So we have to now perform the non-hierarchical clustering with the 3 clusters as a क्लस्टरिंग सॉल्यूशन। तो इफ यू रन दिस, अगर ब्रैकेट नहीं दिया है तो आपका क्या, इतना रन करते हो तो वो आउटपुट नहीं देता है। तो आउटपुट नहीं देता, बट आपको आउटपुट साथ में देता है तो ब्रैकेट के अंदर दे दो, तो इट विल ऑटोमेटिकली डिस्प्ले द आउटपुट। So how many variables are there? 6 variable. How many clusters are there? 3 cluster. This is the mean of first variable in the cluster 1, mean of second variable in the cluster 1, mean of third variable in cluster 1. Similarly, this is the mean of the second variable in cluster 1, cluster 2, cluster 3, likewise. And these are the clustering solution. This is nothing but within variance in the cluster 1, within variance in cluster 2, and within variance cluster. And what is the ratio between two total? It is 75%, 70.5, 75.8%. That means it is making the clustering of the 75.8%. Okay. And suppose if you wish to make the plot of this data, तो 3 क्लस्टर है तो आपको समझना मुश्किल हो जाएगा, क्योंकि हर एक वेरिएबल का वो देगा। 2 क्लस्टर तक हम ये ग्राफ अच्छी तरह से देख सकते हैं, बट 3 में आया तो इट इज वेरी डिफिकल्ट टू इंटरप्रेट। ठीक है, फिर भी किसी को उसमें मीन लगाना है तो हम ना नहीं बोल सकते, बट आई ऑलवेज एडवाइस मेक ए ग्राफ अप टू दी 2 क्लस्टर्स। इफ यू विश टू सी द क्लस्टर्स, क्लस्टर 1 में कौन से डेटा है, तो व्यू कमांड इज देयर, एंड CL डॉलर क्लस्टर में क्या है आपका डेटा है, इट इज शोइंग दैट व्हाट आर द क्लस्टर्स आर देयर, सारे डेटा आपके पास आ गए। ठीक है, तो व्यू, लेकिन हमें उसमें इंटरेस्ट नहीं, हमें क्या करना है, आई विश टू स्प्लिट द डेटा, तो आई कैन हैव दिस कि विच ऑब्जेक्ट बिलोंग टू क्लस्टर 1, तो 4 नंबर का रिस्पोंडेंट 10, 14, 16, 18, 19 दे बिलोंग टू क्लस्टर 1, 1, 3, 6, 7, 8, 12, 15, 17 रिस्पोंडेंट बिलोंग टू क्लस्टर 17। तो 20 रिस्पोंडेंट का स्टडी किया था। Based on this characteristic, they has been classified into the 3 group. Now, as I told you that we have to do the profiling of a clusters. ठीक है, तो प्रोफाइलिंग ऑफ क्लस्टर के लिए आपको क्या करना है, गो टू दी सेंट्रोइड वैल्यू। अच्छा, इसमें देखो सबसे बड़ा मीन किसका है, V1, तो V1 कहां पे होगा, क्लस्टर 2 में। व्हाट इज V1, तो V1 इज शॉपिंग इज फन। अब देखो कैसे प्रोफाइलिंग कर रहे हैं। फिर सबसे बड़ा दूसरा क्लस्टर में कौन सा आ रहा है, V3। ठीक है, तो V3 क्या है, आई कंबाइन शॉपिंग विथ ईटिंग आउट। तो जो पहला बंदा है वो शॉपिंग उसको फन के लिए करता है, और जब भी शॉपिंग कर रहा है तो कंबाइन शॉपिंग विथ ईटिंग आउट, बाहर खाना खा के ही आता है। तो देर इज ए ग्रुप ऑफ पीपल्स हु हैज दिस काइंड ऑफ ए थिंग्स। ठीक है, अब यहाँ पे सेकंड देखो सबसे बड़ा मीन किसका है, V2, और यहाँ पे क्या है, V4, और वैसे देखा जाए तो V6 भी आता है। ठीक है, लेकिन यहाँ पे आपको देखना है कि कौन सा उसमें आता है, मिक्स होता है, वो V2, V4 एंड V6 वैसे जाता है। तो देखो क्या है, V2 इज शॉपिंग इज बैड फॉर योर बजट, V4 आई ट्राई टू गेट द बेस्ट बाय व्हेन शॉपिंग इज डन, एंड V6 क्या है, यू कैन सेव लॉट ऑफ मनी बाय कंपेयरिंग द प्राइस। और एक ही बंदा है V5, V5 कहां पे है, तो V5 आ रहा है थर्ड में, तो क्या बता रहा है, आई डोंट केयर अबाउट शॉपिंग। तो यू कैन डू द प्रोफाइलिंग। फर्स्ट ग्रुप ऐसा है, सेकंड पहला ग्रुप ऐसा है, वो कहता है shopping is bad for your budget. I try to get best buy when shopping, and you can save a lot of money by comparing price. एक तो वो बोलता है शॉपिंग करने जाओ, बजट खराब हो जाता है, वो हम जानते हैं when we go to the shopping mall. Okay, and he is saying that I always try to get the best buys when shopping. तो जब भी खरीदी करता हूँ मैं देखता हूँ कि भाई मुझे मैक्सिमम अच्छी चीजें मिले, और यू कैन से दैट दी बेस्ड ऑन दी स्कीम मिल रही है तब ले रहा हूं, एंड यू कैन सेव लॉट बाय कंपेयरिंग मनी. आप 3 प्रोडक्ट शेल्फ में पड़ी है, यू कैन कंपेयर द प्राइस एंड देन यू कैन बाय. तो दिस इज ए इकोनॉमिक माइंडेड क्लस्टर्स. तो ये आपको देखना है कौन से ऐसे रिस्पोंडेंट है कि जो इसमें जा रहे हैं. तो ये वाले 4, 10, 14, 16, 18, 19. अब इसका जो भी इंफॉर्मेशन आपके मिला, लुक एट देयर एज ग्रुप, look at their social class, look at their income class, whether it is a salaried person, whether it is a business person, कौन से एज ग्रुप में, whether it is a male or female. तो then find out the is there any significant difference between the group of the peoples, पहला दूसरा तीसरा likewise. Okay, so it is saying that these 3 variables are important for a profiling of clusters. Which one? Shopping is bad for budget. I try to get the best buy when shopping, and you can save a lot of money. अगर आपको प्रोफाइलिंग नहीं करना है तो you can say that okay, this is the one group, this is the another group, and this is the third group. और समझ में नहीं आ रहा है तो okay, you can use 1, 2, 3 as a grouping variable in a discriminant analysis and use this 6 variable as a predictor variables, and then you design the decision rule कि कोई भी बंदा आपके पास आता है and it is, we have collected this information of this 6 variable, वो कौन से ग्रुप में बिलोंग होगा. ठीक है. दूसरा है आपके पास क्या आया, सेकेंड ग्रुप इज शॉपिंग इज फन, आई कंबाइन शॉपिंग विथ ईटिंग आउट. तो ये वाला है मोजिला है, आपके जैसा यंगस्टर कि जॉब मिली है नहीं है, लेट अस गो विथ, आज बाहर खाना खा लेंगे, पार्टी करेंगे, खरीदी करेंगे. तो मोस्ट ऑफ द टाइम दी फॉरेन पीपल्स एंड द पीपल फ्रॉम द मेट्रो सिटी, especially both the husband wife are working, they always go for the shopping in the Friday evening. They eating out outside and do the shopping. So that is the group. This is the second group of the people has that characteristics. And third group is that I don't care about shopping. ठीक है. तो ये this is the person who is a lazy minded. So any questions up to this? Anyone? Any questions?
No, sir.
So once again, and a quick revision, when you do the clustering analysis, the thing is that it is a hierarchical or non-hierarchical clustering. Hierarchical clustering we usually perform when we do not have any idea about the number of clusters. So first we perform the hierarchical clusters, we select the suitable distance measure, we select the suitable the cluster forming methods, and then we identify the number of clusters based on the dendrigram. Or we can use in the R, there is a library NBClust which has the several criteria are given to decide the number of clusters, or you can use the k less than equal to n upon p plus 1. Based on that you can decide. Once it is identified the number of clusters, you can go for the non-hierarchical clustering methods and find out the clustering solutions. Once the clustering solution is with us, you can find out the accuracy level of the clusters, you can see the centroid of the clusters, you can identify which peoples belong to the which clusters by using the split command. And last, you have to give the names of the clusters, or you have to make the profiling of cluster, which variables are important for a clustering solutions. And between sum of square by total sum of square giving the accuracy of clustering, it is saying that in our example 75.8% clustering was appropriate.